Hello, everyone. Welcome to today's episode of the Learn Live Azure Core IaaS Study Hall series. Today, I'm your host, Lily Chen. I am a product manager under the disk storage team, and we are joined by my wonderful co-host, Annika Alakamoni, who is a product manager number 2, also on Azure Disk Storage team. Hey, Annika, how's it going this morning?
Hi, Lily. Thank you for the introduction. And hi, everyone. We are very excited to bring this presentation on choosing the right storage for your virtual machine workload live to you guys today. Um, Today, we have David Barber and Raman Kumar, who will be moderating the chat. They both are product managers in the Azure Storage Disks team as well. So if you have any questions, please put them in the chat below and they will help answer them. We will also share the link to our Learn module where you can access the content of today's session. These Learn modules are interactive, and personally, I really like its structure. So we highly recommend and encourage that you check those out as well.
Yeah, we want to make today's learning interactive, so if you have questions at any time, feel free to drop them into the chat or also just to say hi to us.
And also, our moderators will be monitoring the chat and they will also help answer the questions. So let's get started. We have three main learning objectives for today's session. After this session, we hope that you will be able to, number one, identify the different types of disk storage that are available to virtual machines. Number two, understand the capabilities of these different disks. And number three, identify the use cases for each of these disks. With all of this information, you will be able to select the correct disk for your workload. So let's begin with an overview of what a virtual machine and a virtual disk is. So what is Azure Virtual Machine? It is nothing but an on-demand scalable computer resource that Azure offers. Azure VMs are generally used to host applications when the customer requires a lot more control over a computing environment. Azure Virtual Machines use Azure Virtual Disks to store the data, just like how a physical server would use hard drives to store data. And there are different kinds of Azure Virtual Disks, and it's important to know which one to choose when you create a virtual machine. Let's take an example here. A huge healthcare organization has been running their system and storing data on premises, and they now want to move their entire system and storage to the cloud. This means that they want their systems to be running on Azure Virtual Machines. Their system will have many performance requirements, so it is very critical to choose the right disk that would allow their workload to perform optimally while maintaining a reasonable cost. So let's first start by understanding the difference between managed and unmanaged disks. The key difference here is that for managed disk, Azure will manage the storage infrastructure, while for unmanaged disks, the customer will be managing the storage infrastructure. So looking at our example from before, when the customer is looking to move the storage infrastructure of the healthcare organization from on-premises to Azure, they might want to maximize performance while minimizing administrative efforts. So in this case, the customer will want Azure to manage their storage infrastructure for them, so they will end up choosing a managed disk. Now let's look at the different disk roles that a disk can take in a virtual machine. There are three disk roles, and those are OS disk, data disk, and temporary disks. Let's go through each one of them in detail. OS disk, what is it? Every VM can have multiple disks attached to it. Out of these, one disk contains the operating system files, and that disk is called the OS disk. The OS disk will have pre-installed OS, which was selected when the VM was created. And the OS disk also contains the boot volume. One more thing to note here is that the maximum capacity that you can provision for your OS disk is about 4,095 gigabyte, or that's about 4 TB. Now let's look at data disk. Like I mentioned before, a VM can contain multiple disks, and multiple data disks can be attached to a VM. And its essential role is to store application data, database files, website static content, custom application code, or basically any other data that you'd need to keep. And the number of data disks that you can attach to a virtual machine really depends on the size of the virtual machine. Now for temporary disks, each VM contains one temporary disk, and like its name suggests, it stores data only temporarily. It's intended to store data such as page and swap files, and the contents of the disks may be lost during maintenance or when you redeploy your VM. However, on standard reboot of the VM, the data in the temporary disk will persist. The recommendation for the temporary disk is that critical data should not be stored on it since it's very easy to lose the data. These disks are not stored in the storage account and are local to the server. So let's move on to the first demo of our today's session. Here we will create a VM and show how the OS disk and the data disks are created. So this page might look very familiar to all of you guys. This is the Azure Portal homepage, and over here, I'm gonna hit create a resource. And I'm gonna first start by creating a virtual machine. And I'm gonna basically fill out the details that it's asked. I'm gonna use the usual subscription and the resource group that I usually use. For the virtual machine name, I'm gonna give it healthcare org. And for the region, I'm gonna leave everything as default. And I also noticed that the default image that's used is Ubuntu server. All of this looks good. So I'm gonna go hit next to create the disks. So as you can see, the OS disk type over here that's automatically selected is premium SSD. So when a VM is created, an OS disk is automatically created. And over here, you also have the option of creating a data disk. So let's create and attach a new disk. So let's give it a name, a healthcare org data disk, maybe 1. And then I'm also going to change the size to 4 GB. And I'm going to hit OK. So I'm happy with my selection, and I'm going to hit OK. And as you can see, there's one data disk that I've created. Now let's create and review and create all of the settings. So right now, Azure is going to basically validate all of my selections and make sure that the selections are all correct. And now that the validation has passed, I can create the VM and the OS disk and the data disk. Yeah, this process is going to take a few seconds. The document is currently in progress. And this would create all of the resources that we would need, including the network components, the virtual machine, the OS disk, and the data disk.
Annika, I think it's worth mentioning that people can also create disks without going through the virtual machine workflow. So you can create individually create different managed disks and then attach them to your VMs as well.
Yes, that's correct. So in this particular workflow, we created the data disk and the OS disk as part of the VM creation process. And like Lily mentioned, you could also create a managed disk separately and then attach them to a VM. So here, once the VM and the VM is created, we can go to the virtual machine and look at all of the disks that got created. And over here, you can see that the OS disk got created, and we also have a data disk that got created. Now let's continue with our PowerPoint. So this is the same screen that we saw before. In the healthcare virtual machine, if you go into the disk settings, you should be able to see all of the OS disks and the data disks that got created. Now let's look at ephemeral OS disks. So ephemeral OS disks are OS disks that can be created on the local virtual machine storage. These are not saved to the remote Azure storage, and they're mainly used for stateless workloads. So what are stateless workloads? So stateless workloads do not preserve their state and do not save any data to the persistent storage. All the user data and session data will stay with the client. And the main advantage of using an ephemeral disk is that it's got faster read and write latency than managed disks. And since it's located locally in the host, it is free and doesn't incur any storage costs. The biggest downside of an ephemeral disk is that when the virtual machine fails, then that might destroy all the data on the ephemeral disk, and the virtual machine will be unable to boot. For this reason, ephemeral disks are only used for stateless workloads or applications. Ephemeral disks will not work well for stateful applications like MongoDB. Stateful applications use persistent storage, such as persistent volumes, to save the data for use by the server or by other users. So now let's look at managed disks and unmanaged disks in more detail. There are a few advantages of managed disks over unmanaged disks, so let's go over them one by one. Number one, simple scalability. Managed disks are easy to scale. You can create 50,000 managed disks of a type in a subscription per region. This will allow you to create thousands of VMs in just one subscription. Number two, managed disks are also highly available. Managed disks provides 99.999% of availability. We are able to provide this guarantee because managed disk replicates data 3 times in the backend. So if one or even two of your replicas are facing any issues or downtime, your workload will not be affected. Now, let's also touch upon ZRS and LRS disks. LRS meaning locally redundant storage. This replicates your data in the same data center, and this provides at least 11 nines of durability. That's 99.9999999% of durability. ZRS meaning zone redundant storage synchronously replicates your data across 3 availability zones in the same region. And this provides 12 nines of durability. So even if one zone goes down, which is highly unlikely but possible, your workload will not be affected since a copy of it will be stored in a different zone within the same region. Now moving on to the third benefit of using a managed disk. Availability sets and availability zones are both features of a VM, and the advantage of integrating managed disks with availability set is that it prevents the disk from facing a single point of failure. So what is an availability set? An availability set is like a logical grouping of VMs in such a way that VMs are highly available. An easy way to think of this is, let's say you have an application that runs using 2 VMs. Azure will place it in 2 different fault domains so that when one fault domain faces any failures, then only one VM goes down and the other is still up and running. Integrating managed disk with availability set means that managed disks for these VMs will also be stored in different fault domains. So if one cluster goes down due to any failure, then one disk will go down, and the VM instance that uses that disk will get affected. However, your application will continue to run since the other VM instance is still up and running because its disk is not located in the cluster that had the failure. So the advantage of integrating managed disk to an availability set is to protect your application when a failure happens at the fault domain. An availability zone are also similar to availability sets in the sense they also provide better resiliency when something goes wrong. In an availability zone, the VMs are spread across different zones in a region. So if one zone goes down due to, let's say, earthquakes or floods, this is highly unlikely, but it's possible, then your application is still up and running because you will have a VM and a disk in a different unaffected zone. Integrating disks with an availability zone or set is only possible with a managed disk. So let's move on to the next slide. The fourth advantage of managed disk is that you can use Azure Backup to back up your disk. Even encrypted managed disks can be backed up. So what is Azure Backup and why should you use this to back up your managed disks? In Azure, we understand that customer data is very, very valuable, and we need to protect the data from ransomware and even accidental deletion by the customer. Moreover, LRS, locally redundant storage, and ZRS, zone redundant storage disks, cannot protect your data from human errors like accidental deletion. So Microsoft Azure Backup is a cost-effective, simple, intuitive, and also a very secure way of backing up your data. It also provides multi-factor authentication. So this ensures that only authorized users can perform backup operation. And it also saves the backed up data for 2 weeks post-deletion in case the backup was deleted accidentally. The fifth advantage of using a managed disk is that it provides role-based granular access control. So what this means is that you can create a role assignment for a user to be able to do a specific task. In the case of a managed disk, there are a few operations that you can do, including read operations, write, delete, create, etc. And so with Azure Managed Disks, you can allow specific users to be able to perform specific operations. For example, you can allow one person to be able to perform the read operation while allowing another to perform a read and write operation to your disks. And this gives you the control of who you want to give access to, how much of access you want to give, and also what type of access you want to give. Last but not the least, the sixth advantage of using a managed disk is that it can be encrypted. In order to protect your data, managed disks offers two types of encryption. The first one is SSE, also called server-side encryption. This type of encryption is enabled by default for managed disks. The key that is used for these encryption can be either managed by you, and that's called a CMK or customer managed key, or the key can be managed by Azure as well, and that's called PMK or platform managed keys. And the second type of encryption that Azure provides for your managed disk is called ADE or Azure Disk Encryption. And this encryption allows you to encrypt the OS disk and data disk that is used by your virtual machine. For Windows, the drives are encrypted using BitLocker encryption technology. For Linux, the disks are encrypted using the DMCrypt technology. The encryption process is integrated with Azure Key Vault, and that will allow you to manage the encryption keys. And because of all of the 6 features that we mentioned above, which is simple scalability, high availability integration with availability sets and zones, support for Azure backup, granular access control, and support for encryption, you should really consider using managed disks by default. Now let's look at how unmanaged disks work on a high level. Both managed disks and unmanaged disks are stored as page blobs in a storage account, but the key difference is that with unmanaged disks, you will have to create and maintain the storage account manually. You would also have to encrypt your disk manually, and providing granular access to specific individuals is also not as straightforward as managed disks, and that will also have to be done manually. If you're using unmanaged disks and you'd like to convert them to managed disks, you can do this easily by running this command, convert to Azure RM VM managed disks in the PowerShell commandlet. Also note that if you're using a really old VM, it is possible that the disk attached to it is unmanaged, and you can convert those unmanaged disks to managed disks using this command as well. So let's do a demo on how to create a managed disk. So this is the same Azure portal. Let's hit create a resource. And then I'm going to type managed disk. And I'm going to hit create managed disks. I'm going to fill in the same subscription ID, the same resource group. And for the managed, I'm going to name my disk name as managed disks. And I'm going to select the region as US West, US 2. And over here, I see that default size that's selected is 124 GB, and the disk type that's selected is an LRS disks. So I want to chat, and let's see what options I have available. As you can see here, I have the option of selecting an LRS disk or a ZRS disk. So I'm going to select a ZRS disk in this instance. I'm also going to select an 8 GB and click OK. I also have the option of selecting an availability zone, but since I have created a ZRS disk stores data, it stores replica in all of these three zones. So if I try to select any of these zones, it's not going to let me because the data is going to be present in zone 1, zone 2, and zone 3. And that's the benefit of using a ZRS disk. And as you can see, managed disks also provides the option of encryption. By default, the encryption key is managed by the platform, and you can also change it to be managed by the customer. So once I'm happy with all of my settings, I can hit review and create. The validation has passed, and I can hit create to create the disk. So that's how a managed disk is created. It's pretty straightforward, and it's very powerful. Yeah, the deployment is in progress in a few seconds, but we can continue with our presentation. So let's do a recap of everything we went over so far. First, we looked at the 3 types of roles a disk can take, which is OS disk, data disk, and temporary disk. So OS disk contains the operating system files. The data disk stores persistent data, and the temporary disk will store data temporarily, and its data will be lost during maintenance. Then we looked at ephemeral OS disks. These disks provide faster reads and write, but they work well only for stateless workloads since the application data and session data is not persisted. We also looked at managed and unmanaged disks. Managed disks are managed by Azure, and unmanaged disks are managed by the customer. Then we also looked at the 6 advantages of using a managed disks over an unmanaged disks. And the reason is because it's easy to scale, it's highly available, can be integrated with availability sets and zones, can be backed up using Azure Backup, and it can provide granular access control, and it can also be encrypted. Okay, with that, let's do a knowledge check with a couple of quizzes. So the first question we have is, which of these disk roles should you use to store a set of help videos that explain how to use the accounting application? Option A, OS disk, option B, data disk, and option C, temporary disk. I believe there should be a poll in the chat, so feel free to use that to select your answer. We'll give a few seconds for people to get in their answers. The question is, which of these disk roles should you use to store a set of help videos that explain how to use the accounting application? OS disk, data disk, or temporary disk? Okay. I think most of the people who answered got the answer right. The answer is data disk. And just as a recap, the OS disk is used to store the operating system files, and a temporary disk does not store the data permanently, so the help videos could get deleted in a temporary disk, so data disk is the right option. So here's another question. You have a business critical database and you want to store it in a virtual disk with 99.999% availability. What kind of disk should you use? Option A, an ephemeral disk, option B, an unmanaged disk, and option C, a managed disk. So again, there should be a poll in your chat. Feel free to use that to select your answer. We'll give it a couple more seconds for people to answer. Looks like most of you guys so far are getting it right. The question is, you have a business critical database and you want to store it on a virtual disk with 99.999% availability. What kind of disk should you use? Ephemeral disk, unmanaged disk, or managed disk? Okay. Let's look at the answer. The answer is a managed disk. The managed disk provides this 99.999% of availability, which unmanaged disk doesn't. An ephemeral disk cannot be used for business critical databases because the database can be lost. With that, Lily will go over the different disk types that we have available for the virtual machines.
Yeah, thanks, Annika. So we'll go over the different the disk types that are offered on Azure for Azure Virtual Machines. If you've chosen to use Azure Managed Disk for your virtual machine needs, you'll next need to pick the best disk type for your VMs. In this section, you'll learn about the performance and behavior of each managed disk type, so you can make the right choices for your needs. All right. To choose the right disk type, it's critical to understand performance. So performance is expressed in two key measures. The first is IOPS, also known as input-output operations per second. So IOPS measure the rate at which a disk can complete a mix of read and write operations. The higher performance disks have much higher IOP values. The second key measure is throughput. So throughput measures the rate at which data can be moved from the disk to the host computer and off the disk to the host computer. Throughput is also called data transfer rate and is measured in megabytes per second. The higher performance disks have a higher throughput as well. For physical disks, solid state disks or SSDs usually realize higher IOPS and throughput than hard disk drives or HDDs. VMs that you can choose for, virtual disks that you can choose for your VMs are based on SSDs of several types or HDDs. And their performance varies widely based on the actual disk type within these two categories. So let's examine which types are available on Azure. All right. The first type of managed disks that we're exploring is the Ultra Disk. Ultra disks provide the highest disk performance available in Azure. You should consider choosing them when you need the fastest storage performance, which includes high throughput, high IOPS, and low sub-millisecond latency. The maximum performance of an Ultra disk depends on the size that you select, as you can see from the examples on the table. So you can see that the disk size scales IOPS and throughput. So Ultra disks have capacities from 4 gigabytes up to 64 terabytes. A unique feature of Ultra disks is that you can dynamically adjust these performance parameters without having to detach the Ultra disk from your host virtual machine. These on-the-fly performance adjustments can take some time to take effect, but that means that you can start small and adjust your performance as your workloads become more or less I/O intensive. Ultra disks have some limitations with other Azure features. For a complete list, you can refer to the managed disk types documentation. Overall, Ultra disks are well suited for your most data-intensive workloads on disk storage. Examples include top-tier databases, SAP HANA, and other transaction-heavy workloads that need top-of-the-line performance. If you have such a workload, and if other managed disk offerings, such as premium SSD managed disks, have caused performance bottlenecks, consider using Ultra disks. All right. The next one is Premium SSD V2. So Premium SSD V2 managed disk is our newest offering in our managed disk portfolio and is the next tier down from Ultra disks in terms of performance, but they still provide extremely high performance with sub-millisecond latency. Like Ultra disks, the performance of Premium SSD V2 can also be independently configured at any time, making it easier for more scenarios to be cost efficient while meeting your performance needs. The Premium SSD V2 provides a baseline performance of 3000 IOPS and 125 megabytes per second for any disk size that is offered at no additional cost. Now, after 6 gigabytes, the max IOPS a disk can have increases at a rate of 500 per gigabyte, up to 80,000 IOPS, while a maximum throughput can be set, which increases by 0.2 megabytes per set IOPS. For example, an 8 gigabyte disk can have up to 4,000 IOPS, and from that 4,000 IOPS, the disk can achieve up to 1,000 megabytes per second. Unlike the premium SSD, we'll call them V1 managed disks, which we will explore in the next section. Premium SSD V2 managed disks have the advantage of flexible capacity scaling at the 1 gigabyte granularity. This means that you can set your premium SSD V2 disk to any supported size that you prefer, and then make granular adjustments to the performance without experiencing downtime. The premium SSD V2 disks don't currently support host caching, but they benefit significantly from the lower latency, which addresses some of the same core problems addressed by host caching. And the ability to adjust IOPS, throughput, and disk size at any time means you can avoid the maintenance overhead of having to stripe your disks to meet your needs. Like UltraDisk, Premium SSD V2 has some limitations. Again, refer to the managed disk types documentation for our list. Premium SSD v2 managed disks are well suited for a broad range of workloads such as SQL Server, Oracle, MariaDB, SAN, Cassandra, MongoDB, big data and analytics, even gaming applications on both virtual machines and stateful containers. All right, the next is Premium SSD. As I referred to earlier, V1. These managed disks are the next tier down from the V2 Premium SSD managed disks in terms of performance, but they still provide high throughput and IOPS with low latency. The Premium SSD disks don't have the current limitations of either Ultra disks or Premium SSD V2. For instance, they're available in all Azure regions, and they can be used with virtual machines that are outside of availability zones. Unlike Ultra and Premium SSD v2 disks, you can adjust performance without detaching these disks from their VMs. You cannot adjust performance without detaching these disks from their VMs. Also, you can only use Premium SSD managed disks with VMs that are compatible with the Premium storage. All right, with Premium SSD, these performance figures are guaranteed. There's no such guarantee for our standard tier disks, which can be impacted occasionally by high demand. So if you need higher performance than what the standard disks can offer, or if you can't sustain occasional drops in performance, consider using the Premium SSD managed disks. Also use Premium SSD when you want the highest performance, but can't use Ultra disks or Premium SSD v2 because of their current limitations. Premium SSD disks are a good fit for mission-critical workloads in medium and large organizations. It's worth noting that you can migrate a disk to Premium SSD managed disk at any time if you found that the performance of the lower tier standard disks aren't good enough for your workloads. Standard SSDs in Azure are a cost-effective storage option for VMs that need consistent performance but at lower speeds. Standard SSDs aren't as fast as the premium or ultra disk products, but they still have latencies in the range of 1 millisecond to 10 milliseconds and up to 6,000 IOPS. Standard SSDs are available on all Azure VMs, no matter what size. So this table has examples that illustrate the performance characteristics of standard SSDs at several sizes. So you can see up until E60 disk size, you get a max IOPS about 500, but it scales as you increase the capacity of the disk. These performance figures aren't guaranteed, but are achieved 99% of the time. So use standard SSDs when you have a budgetary constraint or a workload that isn't too disk intensive. For instance, web servers, lightly used enterprise applications, and non-production workloads can all run on standard SSDs. The last type of managed disk is our standard HDD product. HDD stands for hard disk drive, which means that if you do choose standard HDDs, data is actually stored on conventional magnetic disk drives with physical moving spindles. Performance and speeds are more variable than for SSDs, but latencies offered by standard HDD is still under 10 milliseconds for write operations and 20 milliseconds for reads. As with standard SSDs, you can use standard HDDs with any Azure VM. This table illustrates the performance characteristics of the standard HDDs in several sizes. So standard HDDs are really great if you want to minimize costs for less critical workloads and for using them in development or test environments. So to summarize, Ultra disks are a good choice if you want flexible performance configuration model to achieve the best performance for your IO-intensive workloads and top-tier databases. Premium SS2 v2 disks are also great, but well-suited for a broad range of production and performance-sensitive workloads for databases, big data, and gaming on virtual machines and stateful containers. The original premium SSD managed disks are the next tier down, and they still provide high IOPS and throughput with low latency. They are a great choice if you want to use the performance offered by the premium tier disks, but you can't use Ultra or Premium SSD v2 due to their limitations. And Premium SSD v1 are a good fit for mission critical workloads in medium and large organizations. Standard SSDs in Azure are a cost-effective storage option for VMs that need consistent performance at lower speeds for lighter workloads, such as web servers, lightly used enterprise applications, and test servers. They're an especially good choice for customers with varying workloads supported by on-premises HDD solutions. The final managed disk offering is our standard HDD, which is recommended for when you want to minimize costs for less critical and also latency tolerant workloads, and for use in dev or test environments. All right, we're at another knowledge check time, so everyone hop onto the poll. Our first question is, you need the best disk performance for a new virtual machine. Which disk type should you use, assuming all the disk types are supported in your region of choice? A, Ultra disks. B, Premium SSD, V1, I'll clarify. And then C, Standard HDD. So let's give people a few seconds. But yeah, Annika, which one do you think?
I don't want to give up the answer too soon. But just as a recap, the Ultra disks and is the newer offering when compared to the premium SSDs and standard HDDs, right?
Yep, that's correct. All right, let's see what people voted. So it looks like we got 80% of the votes for Ultra disks, 20% for premium SSD, and 0% for standard HDD. Let's see. All right, yeah, the answer was Ultra disks. Yeah, so to recap, Ultra disks offer the best performance out of all the managed disk types on Azure. All right, the next question. You have a medium-sized application with high I/O requirements, and you need to optimize for the best price for your performance while guaranteeing that level of performance. Which disk type should you use? So let's see what people are voting. I'll go over the question one more time. You have a medium-sized application with high I/O requirements, so you need to optimize for the best price for your performance while still guaranteeing your level of desired performance. Which disk type should you use? All right, looks like 75% of people have voted for standard SSD. 25% have voted. I guess it's changed now. Okay. 40% of people have voted for premium SSD v2, A. 60% have voted for B, standard SSD, and C, 0% have voted for that. Let's see. Yeah, the answer was premium SSD v2. So the standard tier disks like standard SSD and standard HDD don't guarantee a minimum performance, but they are achieved, I guess, to the 2.9s, but they aren't as reliable as the premium SSD v2 for the performance that you want. The premium SSD v1 also don't allow you to make granular adjustments, but the premium SSD v2 allows you to make adjustments to the performance and capacity. For these reasons, use premium SSD v2 managed disks. All right, so in the last part of this module, we'll walk through an example of an application that is looking to migrate to the cloud, where many of the systems will be running on Azure virtual machines. These systems have an assortment of performance and usage profiles, and they'll need to balance performance, features, and cost to identify the right disk for each system. So yeah, let's examine in detail the disk type choices architects must make for this proposed Azure application. So suppose you're in a healthcare organization and you have a business critical system that manages stocks of prescription drugs and ensures that practitioners have them available at all times for their local clinics. You want to migrate the system into Azure with as little modification as possible, and you want to create a set of virtual machines in Azure that matches your current physical servers, and then migrate the system. Before the migration, you want to select the right disk types for each virtual machine. So we'll examine the requirements for each virtual server in the proposed Azure infrastructure and see why each particular disk type is optimal. All right, the first part is the production database. So first, you want to architect the virtual machine that will host the production database for your prescription drug stock system. This system is business critical, so it's going to be used by the majority of your employees all around the world to do their jobs. The database server is in an on-prem system that is heavily utilized, and the physical disks that are in the system run close to their capacity in terms of IOPS and throughput. You monitored and analyzed the performance of your on-prem system, both during typical periods and during periods of peak demand, such as during a successful marketing campaign. The study shows that the fast disks and low latency underpin the system and that any drop in performance will affect all your users. So to ensure that your current good performance continues after the migration to the cloud, you want the disks that store the databases to support 50,000 IOPS and throughputs up to 1,000 megabytes per second. This requirement makes the decision simple. The maximum size for premium SSD managed disk is the P80 tier, but this size only supports a maximum IOPS of 20,000 and a maximum throughput of 90 megabytes per second. And only the largest sizes of premium SSD V2 and Ultra disks support the performance that you need. Now remember that the premium SSD V2 and Ultra disks can only be attached to VMs and availability zones. This requirement provides high availability because the virtual servers aren't vulnerable to a data center-wide hardware failure, which means that you should use managed disks, which Azure will automatically replicate across the availability zones where the VMs are hosted. VMs and disks. All right, sorry about that. All right, the database warehouse servers are the next part. In this system, data from the production database is regularly exported to this data warehouse and is restructured to make it easier to analyze long-term trends. These servers also host data cubes that are designed to support your complex reporting needs. In your on-premises system, there's a data warehouse server in your main data center, and also several in regional offices. You've created a virtual machine image for these data warehouse servers, and you'll use it to simplify the deployment of multiple instances of the virtual machine in different Azure regions. Your analysis indicates that these servers require high-performance disks, but not the extreme performance that is required by the production database server. In this case, the highest performance disks for consideration are the premium SSD V1 managed disks, also the premium SSD V2 and Ultra disks. However, Ultra disks and premium SSD V2 managed disks don't currently support virtual machine images. As a result, the premium SSD managed disks V1 are the optimal choice for data disks in this workload. None of your requirements for data warehousing require unmanaged disks, so you can choose managed disks to reduce any administrative overhead. The second to last section is the standby database server. So in your on-prem system, you have a standby server that runs basically a replica of the main prescription drugs stocks database. So on the rare occasions when the main server fails, database queries are redirected to this server so that your users experience no interruption in service. You want a similar standby VM in your cloud-based system. Now, because this VM won't be used most of the time, you'll be asked to implement it with a limited budget. Your architects consider that a drop in performance is acceptable during the rare failures of the primary VM. You find that the budget is unlikely to stretch to the premium SSD managed disks or premium SSD v2. In these circumstances, the standard SSD managed disks are the best choice because they have equal or better performance than the equivalent size of the standard HDDs and have more consistent performance. And then the last part of the system is the administrative web service or web interface. So your on-prem system includes a set of stored procedures that implement maintenance routines on the data. There's also a set of data views that the admins can use to monitor the performance of the database. To make life easier for the admins, there's a web server for your on-prem system that hosts a site that your administrators can use to run these stored procedures and view performance reports. You want to migrate this system into the cloud and host it on an Azure VM. Again, you want to minimize costs. This site is used only by a team of 20 administrators and places a very low load on its disk drives, which are only used to store the web app's code files. The server doesn't have strict availability requirements because it's not a business critical system. In this case, you can minimize costs by using standard HDDs in the web server. To minimize administrative requirements, you can use managed disks again. All right, so now we're at our final knowledge check. So everyone get out, go back to the poll link. Here it is. All right. So for the administrative web interface server, suppose you want to use Azure Backup to protect the contents of the VM's disks. How would this requirement change the disk type that you choose? Would you use A, use standard SSDs and standard HDDs? B, use premium SSDs instead of standard HDDs? Or C, no changes needed? I'll go through it one more time before I take a look at the results. So for your administrative web interface server, you want to use Azure Backup for protecting the contents of the VM's disks. How would this requirement change the disk type that you choose? A, use standard SSDs. B, use premium SSDs instead of standard HDDs. Or C, no changes needed. All right, I'll give you guys a few more seconds. Get those votes in. All right. It looks like 33% of people voted A, use standard SSDs instead of standard HDDs. 66% voted for use standard SSDs instead of standard HDDs. And C received 0 votes. So let's see. Answer is actually C. So if we remember from Annika, what Annika presented earlier, all managed disks are actually supported by, the Azure Backup feature supports all managed disk types in Azure. So no change is actually needed in this case. That's a bit of a trick question. I apologize for that. All right, and then our last question. For the standby database servers, suppose that your requirements change. You decide that a minimum IOPS of 1,100 is absolutely required at all times. How would this requirement change the disk type that you choose? Would you A, use premium SSDs instead of standard SSDs? B, use standard HDDs instead of standard SSDs? Or C, use unmanaged disks instead of managed disks? Oh, there's my mouse. I'll go through this one more time. This question's a little bit tricky, but don't worry. For your standby database servers, suppose that your requirements change and you want to achieve a minimum IOPS of 1,100 at all times. So how would this requirement change the disk type that you use? Would you A, use premium SSDs instead of standard SSDs? B, use standard HDDs instead of standard SSDs? Or C, use unmanaged disks instead of managed disks? All right. Looks like 75% of people have voted A, use premium SSDs instead of standard SSDs. 20% of people have voted B, use standard HDDs instead of standard SSDs. And 20% of people have voted C, use unmanaged disks instead of managed disks. The answer is, it's A. All right, so the reasoning is that although the larger standard SSD sizes can support this level of IOPS, the performance isn't guaranteed and can drop below 1,100 IOPS. So in this case, the premium SSDs do have a guaranteed performance level. For B, the standard SSDs have a greater performance reliability than the standard HDDs. And for C, I guess it depends, but for unmanaged disk, you have to manually configure these IOP limits. So to reduce any administrative overhead and to change your IOPS through Azure's portal, you can use managed disks instead. All right. So in summary, So first of all, I just want to thank everyone for staying with us, and congrats on reading the end of today's session. So at this point, we have identified the different types of disk storage available for use with virtual machines. We've explored the capabilities of the different disk storage types, and we've discussed the use cases for each type of disk storage. So thank you again for learning with us, and we hope you found today's session helpful for choosing the right disk storage for virtual machines. So again, here's a link for our today's episode. You can watch it on demand at your own time at the link that's scrolling around down there, or scan the QR code. So if you've missed anything, or if you want to review the actual module yourself at your own pace, you can find the module at the link above and complete other interactive learning exercises as well. So today, this is part of a series of 7 episodes, so don't miss the next one. Our next session will be on January 12th in the new year, so continue your learning or explore previous episodes of the Learn Live Azure Core IaaS Study Hall series by checking out the links to the side. Yeah. So thank you everyone for your time, and thank you Annika for being an awesome co-host. I hope everyone had fun.
Yeah, thank you everyone, and good luck with your future learning endeavors on Azure.